All right, let's go ahead and jump on in here. Hopefully everyone is enjoying the nice shift in weather. Been a rainy day, but at least it's been a cold day, so yay for that. Um, Go ahead and dive on in here. How are we feeling about SQL? Spent some time in Khan Academy yesterday. We got just our first taste of it, little different syntax. Hopefully we're seeing why we would use it or how we would use it. We're getting the relational part of it with joins. We're understanding the select statements, and we've already seen our insert statements. We're seeing a little bit more on table structure. How are we feeling in general? All right. I will take no news as good news, hopefully. Um, Shannon, it's always nice to know that you are appreciating my teaching so much that you feel that you're at a loss when class is over. Totally kidding. Definitely need more practice, and it's only been a day. Yes, that's totally fine. So here's the plan. We are going to finish up the rest of the lessons in Khan Academy. Then we are going to just practice getting some data around, right? We're going to use one of the data sets that they provide, and we're going to go through and practice things from that, right? How do we write a select query? How do we do those joins? How do we get that kind of information going? And then we are going to, in the second half of class, install two applications, one which is called Beekeeper Studio, and then the other one is called Postico. I'm sorry, Postgres, which is Postgres app, which is a way that we are going to get our database up and running. So we are going to do the setup in the second half of class. On Wednesday, we are going to actually change up the order that I've done this, because I think it's really hard to learn all of this stuff in a vacuum and then expect to go do it all in the API. So we're actually going to move some of the API stuff forward, learn how to build our own API, and then connect that in with the database. And then we're going to go back and learn about database design and kind of the last of the stuff over there. So that's what is coming up. We'll set up Postgres in the second half of class. A couple more students will probably be joining us because they finished up their homework, so we will get that going then. Tomorrow, we will actually install our first API or get our first server set up, do all of that cool stuff. And then on Thursday, you are stuck with me. OpenHack was pushed back this week. It is not this upcoming Thursday. So if you didn't see that message in Slack, you are on the hook for attending class this Thursday. You are off the hook next Thursday for OpenHack then. So that is what is coming up. For now, we are going to jump back into Khan Academy. We'll use that for the first half of class, play around, see if you guys have any questions, and then we will get set up in Postgres for the second half of class. Anyone have questions before we dive in? Okay. In that case, I am going to post the link in the chat. I will share my screen and we will dive on in here.
I'm back with just the table about students this time. I've added one more column to the table, buddy ID. See, I decided that every student should have a buddy, somebody that they can pair up with, do assignments with, study with, all of that. Now, the buddy ID is what it sounds like. It's an ID that relates to the ID of the student that they're buddied up with. So, for example, here, Peter is buddied up with 2, and 2 is Alice. Let me just do a select that should make that more clear. So select the ID, first name, last name, buddy ID from students. Okay. The interesting thing here is that this buddy ID is a column in a table that's related to another column in the same table. That's a bit different from before, where we'd have columns related across different tables. So, what if we wanted to show the names of each student next to the email of the buddy? Not just the ID, the email. To do that, we need to actually join the students table with itself, because the 2 bits of related data that we need both happen to be in the same table. We can do that by, let's see, so we want the first name, last name, email. So to join students with itself, we're going to write from students and then join students. Okay. All right. Okay, so we get an error. First name is an ambiguous column. And that's true. We're telling to select first name, but it's joining across 2 tables, and both of these tables have the same column names. And before, we would just prefix these with the table names, but we can't do that here because actually they're both named students. So we need to give it a way to distinguish between this one and this one, even if they're kind of the same thing. And we can do that by giving one of them an alias. So we're going to write the alias right after here. The alias is like a nickname. So here's the alias, buddies. And then we just have to specify that the email is coming from buddies.email. Haha. There we go. Now we're seeing too many rows, way too many rows, and that's because we don't have an on clause yet. So it's just joining every possible row with every other one. Now our on should check that the buddy ID from the students table, that first one, matches the ID from the second table, buddies, or what we called buddies. Haha! Now we can see Peter with Alice's email address, Alice with Peter's, etc., etc. To make this results table even a little more clear, I'm going to rename Buddy's email as Buddy email. Okay, so now it's a lot more clear that we're looking at Peter Rabbit and his buddy's email. Cool. Now this type of join is called a self-join, and that's because it's a table being joined to itself. You can try this out in the next challenge, and I'll show you one more way to use self-joins in the talk through after. I hope you'll join me. If not, just join yourself.
So self-join's kind of weird, right? Of like, why would I ever need to put a table next to a table to get one more table out of it? But the general idea here is, hey, when I present information to an end user, I'm going to run some query, and I don't want to tell the end user that Peter Rabbit's buddy ID is 2. I want to include whatever that buddy ID information is, right? So if we look at our entire students table, we know that this ID, this buddy ID, is actually referencing a different row in my students table. So what I am able to do is kind of trick SQL into joining on itself. And I can say, hey, take this table and join the table to itself. So we've got 2 copies of it. Now, how are we going to align those 2 different tables? We're going to line up with whatever the buddy ID is in the first copy of the table, students, to whatever the ID is in that second copy of the table that I kind of made. Now that I've got those 2 together, I am able to kind of take my buddies table, which is, again, just a copy of the table, but lined up with the first one, and able to line that up with the second one, if that makes sense at all. So go ahead and practice that in this next challenge. I'll give you guys a couple minutes to work on it, and then we will do it together. Where are we at? We're not another minute, or we want to attack it? One more. Good now? Let's give it a try. Okay, we've got all the Harry Potter movies with a sequel ID column. Now, sometimes it's way more important to understand the data that's in the table than it is to actually like dive in and write the query all at once, right? And we can kind of see this data here, but it's kind of hard to understand like what actually is 5 here or 6 here, right? So if we click on the movies table, it's going to write a statement for us, a query for us that says select star from movies. So now we can see, all right, here are all of these movies, right? Harry Potter and the Philosopher's Stone, the very first movie, and its sequel ID is 2. So this 2 is lining up with this 2 down here. That is saying that after the Philosopher's Stone, Chamber of Secrets was the second one that came out from there, right? So all of these IDs are lining up with whatever ID comes next in the table. So what we are able to do here is say, hey, what do we want to select? We want to, that will show the title of each movie. So we're going to say movies.title. And we're also going to show the sequel .title. We're going to select, yes. Oh, my screen share was paused. Sorry. Thank you. Okay, so we do our movies title, our sequels title. We're pulling it from the movies table. Give me 1 second here because I totally need to reference the end of that last video. Here we go. Okay, sorry. From the movies, we are also going to join in another copy of the movies table, but this time we're going to alias it as the sequels. And then we get a ton of them, right? Part 1 is like linking to every single sequel here because it doesn't know how to merge the two tables together. So we say on movies.id is equal to our, oh, nope, I'm sorry, our movies.sequel ID is equal to our sequels.id. Now we've got this lining up. Philosopher's Stone, Chamber of Secrets comes next. Chamber of Secrets, then Prisoner of Azkaban comes next. And then we've got movies title, the sequel title. We're doing the join. We've got the what am I missing?
Max Alizé put a
Yes.
suggestion in the chat.
You don't need the, oh, maybe here as sequel. No, that isn't there. Left outer join it. That's a good suggestion. Okay, why did we need that? Well, go back and read the question prompt, right? It says issue a select statement that will show the title of each movie or null if it doesn't have a sequel. Well, let's think about that. If we're doing an inner join, it's only going to take where the two tables line up with each other, right? But we don't want only where they line up. We want all of the movies from the first one, even if it doesn't have a match of the second table, right? And so that's when we want to do that left outer join, because we're saying, hey, take all of the movies, even if that movie doesn't have a sequel that lines up on that join. If I take this out, it should hopefully, yeah, it still works. Okay. Any questions on that? Feel like we understand? Okay. On to, oh, that was just a one-step challenge. All right.
Sorry, I just have
Yeah.
one question. I think, okay, I got a little confused here. So I started with the movies.title, and then I think what tripped me up a little bit is the sequels.title.
Yep. So
So
think about this is we're joining the table to itself, but it's like, well, what do you want to call the thing that you're making a second copy of it? So we basically tell it, hey, I want to join in the same movies table again, but I'm going to rename that copy of it called sequels.
okay.
Then I can tell it, hey, line up movies, which was our original table, right? With whatever the sequel ID is in that table compared to the sequels in our actual, in the copy of the table that we just made. Does that make sense?
Yeah. And then is the sequels.title, is that referencing because we made that other column down below?
We renamed the copy of the table, we aliased it called sequels, and that's what we're lining up with the title up here.
Okay.
So think about it like, let me try this. All right, so we've got all of our movies, right? Let's see, this is probably going to blow up in my face, but we're going to try it anyway. Let's try it in numbers, see if that will work for me. Okay, so we've got all of our movies here, right? And now we say, all right, we're going to, anything on the left side here is going to be our movies table. We are then going to come over here and copy that entire table. This we're going to call our sequels table. Now, how do we line up this with this? We are going to say, hey, movies table is on the right. Take whatever the sequel ID is from the movies table and line it up with the ID from the sequels table. Now, if I say movies.title, I'm going to get Harry Potter. But if I say sequels.title, I'm going to get Chamber of Secrets. Because we are basically joining this table over to this ID. So anything over here, we call it our sequels table. Anything over here is still our original movies table.
All right.
Did that help?
Yeah, I think I don't know. Like, I get it. I think I just need to like go through it a little bit more, and then it'll like really set in for me.
Sure. And the good news is we won't be doing a ton of self joins. This is more just to understand, like, if all of our data is contained in one table, but we still want to be able to reference other rows in that same table, that's when we want to use our self join. Right? Because if we think about it, the end user doesn't really care that the sequel is ID number 2. The end user wants to know that the sequel to Philosopher's Stone was Chamber of Secrets. Shannon.
So mine looks right, but it's not showing like the next step button. Is that not supposed to be showing?
Share your screen. Let's take a look.
Okay.
Yes, Palosh, that would work as long as you're using SEQ for the column names and all of that kind of stuff. Comment out your line 23. It's seeing the results from the first query. So just single click and then command slash, and there you go.
Oh, okay. That was easy. Thank you.
Yep. Tara, what's up?
Oh, that might be maybe that's my problem too. Because mine just is not taking, like, I did start over to erase everything that I had commented out. I mean, and it just is still saying, like, we can't find the column name sequels dot title.
Share your screen. Let's take a look.
And I just did what you said and commented out the select for movies.
Wills.
Oh, what? What?
Well,
Oh, it has to have an S.
Yep, and then you need an S down here as well.
Oh, wow. Okay, thank you.
No
I
problem.
tried something. I kept not understanding why it wouldn't take me to the next. I don't know. I tried it a bunch of different ways, but
Not a problem. Yeah, we just need consistency there, right? So if we are, could you guys see my numbers thing when I was showing that before, or is my screen share off?
we can
could
see
see
it
it?
now. We
Okay.
couldn't see it the first time.
Oh. Okay, let me just go through that visual one more time because that can I realize I shared my Chrome window, which is a better video experience instead of the entire desktop. Sorry, my bad. What I was trying to say earlier was our movies table, we take the whole movies table, we put it over here on the left. Then we basically make a copy of the table, we put it over here on the right, and this is what we called our sequels table, right? Then we said, well, how do we line up the information here? So this sequel ID 4, we know sequel ID 4 over here is Harry Potter and the Goblet of Fire. So when we do our join, this is our movies table, this is our sequels table. So we say line up the sequel ID from the movies table here, line it up with the ID in the sequel table over here. I do appreciate the irony that we are talking about sequels in the SQL programming language, but we'll leave that meta thought for later. Does that make sense? Does that help?
It does, but I guess I'm still confused by if we renamed it, if the as statement says that we're renaming it to sequel, then why do we have to add S's to movie sequels and sequels.id?
We don't, we just have to be consistent. So we could call this seek if we called this seek and we called this seek as well.
Oh, okay. But you see how it like went away from the next step? So like in the real, like in live environment, that would work, but just
Correct.
not here.
Yeah, I'm actually surprised that it didn't work here. I'm very surprised by that. Well, no, now I lost it entirely. Oh, because I have my select up here. Sorry. Okay, so now that should work. If I put this down to seek, this to seek, and this to seek, that still works.
Okay, that makes sense then.
Natasha.
Okay, so I know I missed the beginning of this module yesterday, but are we only working in Khan Academy right now, or are you
Yes.
in actual, okay, so I was gonna say, where do you put this information in what program?
Only in Khan Academy. Second half of class tonight, we will break outside of Khan Academy and actually get it set up so you've got a real database on your computer.
Okay,
Yes. And so SQL, all it boils down to is you can hear it pronounced SQL or SQL. Those two are interchangeable. If you write it, however, like on a resume, it's always the letters SQL. SQL is a structured or standardized query language that is a way for us to perform 4 database operations: create, read, update, and delete. CRUD. So create, we are doing right here with our insert statements. When we insert, we always insert into tables. And hopefully this isn't a boring review for everyone. Hopefully this is just recapping what we learned yesterday, right? So we always insert data into tables, and tables always have what we call a schema, which is basically the structure. What are the columns going to be of that table, and what are the data types of those columns? So up at the top here, we've got this create table syntax that is saying, hey, here are going to be all of these columns. Title is going to be text. The year it was released is going to be an integer. Then once we create the table, we are able to insert data into that table. That's our create. Then we've got to be able to read that data back. So we use something like a select statement. And if we say select star, it's going to select all of the columns from this table. Well, now we get a little fancier, right? We can say, hey, we only want certain columns to come back, or SQL is what we call a relational database. So it is a way for us to say, hey, we've got students and we've got teachers. We can just store teacher ID on the students table, then get all the information about the teacher by joining or relating the teacher ID in the students table to the ID in the teachers table. And so that's what we call a join. What we just dove into was, well, what if the data that we're looking to join it from is all from the same table? And naming convention here, there's less naming convention here than there is in kind of JavaScript variable names. It's kind of whatever makes sense for you, right? So we could really call this copy of movies table if we wanted to, and it would still work. We just want to be consistent. Good. Any questions on that?
Okay, yeah, sorry. I have one more. So I think
Yeah.
what my question was like, so once we name that, it's gonna create that anyway, whether we've created like a name for it or not. So like when we put the SEQ and then we create like that join table down below, like is the table already made before that?
No, the table is getting generated based off of whatever query we write here.
Okay.
So if we just said, like, if we just did our, if we just did our select star from movies, this table, all this data exists in the database, right? If I comment this out, this data still exists. So think of it kind of like a PWD in the terminal. We inserted all of this data, but we really don't have any way of knowing that data got inserted, right? We can CD our way into whatever directory we want, and the CD worked, but we have no way of knowing if it worked or not without writing that select statement to try, or that PWD command to try and get that information back out. So the tables in the database are just movies, right? We aren't actually creating and saving this table. We're just happening to look at the results of the query in a table format. So movies is the table. compared to our select statement down here, even though it shows up in a table, these are really just our query results. All the actual data is still down in movies. Did that help?
Yeah, I feel like I don't know what my mind is doing right now, but I'm just gonna sit back and watch.
Let it coast. We're only on day 2. And if you're still feeling this way by like next week, let me know. Unless anyone else is kind of feeling the same way of like, I get what you're doing, but I don't get why you're doing it. Natasha, go ahead.
Okay, so queries are referring to any of the actions you're putting in on this table, like the select, the join. I don't see what other options there are, but is
So
that what it's referring
this is
to?
all one big query. The
Oh.
insert is one query. This insert is yet another query. The create table up here is a query as well. Whenever you see that semicolon, it's the end of this query, and then it's going down and executing whatever the next query is.
Uh-huh, okay, thank you.
Corwin.
So once you do the select, you do movies and sequels.
Mhm.
The as sequel, that's setting that as like, that's just one query, right?
It's just
It's just-
naming this column over here.
Okay. And then
This
from
is
it's
just
pulling it
saying
from
like as follow up movie. It just puts follow up movie up here. But that's only in the results of the query. That's not actually modifying the table structure at all.
I was just making sure that was just the name of the table itself. Okay.
It's the name of the column.
I mean, my bad, not table.
This
column.
is the
Yes.
name of the alias of the table based off of kind of the second copy we made of it from the self join.
Okay.
Select movie titles, then next to it display the title of the sequels based off of the other data that is in this table. Yes.
Okay, I get it now.
Right. If when we first started, this was the only table, right? And we're like, here's Philosopher's Stone. Now, as a human, we can say, well, sequel ID is 2. Where is the ID of 2? It's right here. 2 must go to Chamber of Secrets. But how did we figure that out? We looked at this and then we went back into the table, got out this information and said, okay, we want this and this to show up together. But we the computer can't keep track of that. The computer doesn't know that logic. So instead, we make a second copy of it. We call this SEQ. And then based off of SEQ, we can line this up to this over here. So we can say, take whatever the sequel ID is from the movies table, the original table, line it up with whatever the ID is in the table that we copied. And then based off of those two lining up, go get the SEQ.title. Then show this and this next to each other. And Natasha, there should be a semicolon at the end of it. Khan Academy just isn't picky if it's the last. And I think normal SQL is like this. If it's the last command that you wrote and there's nothing after it, it just assumes to put a semicolon at the end. Shannon, we rode that roller coaster from, I think I'm getting it, to no, you're confusing me more, to, oh no, I actually get it better now. Good. Allie, who is number 2 working for is like one of my favorite scenes in a movie ever. Like, cannot watch without hysterically crying from laughter. We good? All right.
Now I want to show you a combination of joins and self-joins. So this time I'm back with multiple tables, tracking the students and their projects. Now, since I have students working on great projects, I want them to review each other's work in pairs. For example, hyena habitats should review carpet physics. That's why I've created this new table, Project Pairs, and all it stores is 2 project IDs that are paired with each other. Now, let's see. What do I see if I select star from project pairs? Ugh, okay, it's just a bunch of numbers, a bunch of IDs, all the IDs that are mapped with each other. It is not the most human readable output at all. What I'd like instead is rows of project titles paired with each other. The project titles are in the student projects table. So that gives me a clue that I need to somehow join project pairs with student projects. Let's see what happens if I do that. Aha! So now we see project IDs and project titles in each row. What I eventually want in the results table is to see 2 project titles in each row, not just one. So that's another clue that we need to do another join, a self-join of student projects with itself, so that we can get those same column values twice. Now, it may not be obvious how to add a self-join at this point, because we already have a join. If we want to add another one, we can actually use the join keyword again. So join student projects, and we need to make sure we give them different aliases so that they're not ambiguous. So A and B. All right, so now we've got a lot of stuff in this results table, but if you'll scroll, you'll see that the project titles show up twice in each row. So maybe let's make it easier to see. A.title, B.title, great. But we still have way too many rows because we're matching every row with every other row, and we haven't added the on clause, the very important on clause. So we're actually going to add 2 on clauses, one for each of the joins. So on project pairs, that's project 1 ID equals A.ID. And then on project pairs dot project 2 ID equals B.ID. Aha, there we go. So thanks to this combination of joins and self-joins, we can see a nice list of project titles paired with their project title. Now, you can use as many joins in your query as you need to get the data that you want, but generally, more joins mean slower queries. If you're interested in how to figure out if your queries are slow and making them more efficient, we'll talk about that soon. So stay tuned, keep at it.
Okay, so again, we need to understand the structure of the data before we write our query, because if we don't understand that, we're not going to be able to write the query or understand what the query is doing. We've got this thing called project pairs up here. Project pairs is referencing something in this student projects. So the idea here is we are saying, hey, based off of whoever is paired together, one of those students is working on carpet physics and the other student is working on the hyena habitats. And because those 2 people are working together, we want to show that information together. But that information is coming from project pairs, so we start our from query there, but then we also need to know what are the name of those projects. Well, project ID here is going to line up with an ID in student projects, and project ID 2 is going to line up with a different ID in student projects. So here we did a double join, which is actually pretty common, but we did a double self join, which is a little less common. But the general idea stands here. hey, we need to join to 2 different copies of the student projects. This is going to be our student 1 project ID. This is going to be our project ID 2. Then we line all of that information up from project pairs and pull out the A title and the B title, the project ID 1 title and the project ID 2 title. Do we understand that before we move on? Okay, go ahead and try this next challenge. This is a 2-stepper. We've got a database for a friend networking site with a table storing data on each person, a table on each person's hobbies, and a table of friend connections between the 2 people. In this step, write a join to display a table showing the people's names with their hobbies, right? So we're working with the person's table because that's where full name lies. And we have to join that in with a hobbies table so that we can actually say, hey, this person's name enjoys this hobby over here. Give it a try. Vote in the poll that I just launched when you have it working or you're ready to go over it. equal is one of those very frustrating things because it's broken, it's broken, it's broken, and then it works, and there's no in between. So if you can practice breaking down those queries and saying, all right, what am I really trying to accomplish here? I'll give you guys one more minute here, and then we will roll on to the solution because we've got one more section we got to get through, which is probably the most important section of all of these lessons. And then we will go on our break and learn how to install Postgres and Beekeeper after the break. All right, let's give this a go. First one, we just need a simple join. We're going to select the person's full name and the hobbies name from the person's table. And we are going to inner join the person's the hobbies go away hobbies person ID sorry, I did this wrong. The hobbies person ID to the person's ID. Right, we're saying, hey, line up whatever the person ID is here with the ID here. We're joining both of those tables and we're pulling in the full name from the person's table and the name of the hobby from the hobbies table. My microphone bubble. I didn't know I had a microphone bubble.
It's asking if you want to switch the microphone, but you moved it up, so now it's not covering anymore.
To switch the microphone, I don't even have that on my screen.
We see it.
Oh, hold on, let's. Did that fix it?
It's still there, but it's not covering your material.
All right, well, let me know if that happens again.
Thank you.
Shannon, that's like Clippy. Just go away. I'm trying to write my damn letter. Okay, second step here is now uses another select with a join to show the names of each pair of friends based off of the data in the friends table, because we got three things that we're working with, right? So we're gonna say select, and we're going to say we're actually going to cheat here. We're going to say from all of this data is coming from the persons table. And we are going to join in a copy of the persons table as peeps A. And we're going to say on persons.id lines up with my peeps.person1 ID. And from that, we can select the peeps A dot full name. Peeps A and peeps A person 1. Does it not like my casing? No. Oh, sorry. This is called the friends table. My bad. And it should be full name lowercase, and full name is coming from the persons table. My God. Okay, sorry about that. The as Taylor, are you sure you did the second one as well? There's no way you could show the names of each pairs of the friends without knowing who was each other's friends. Okay. And we don't need the as, it's kind of annoying. We use as if we're aliasing this as like friend one. We use the as up here, but we don't use as when we're aliasing the table down here. So now we join that in another time. We're going to join the friends table again, but we're going to call this peeps B. And we're going to say, hey, on the friends, on the peeps B, oh my God, I cannot spell for the life of me, friends. On the peeps B table, get the person 2 ID and line that up with the person's ID. And then we can select the person's full name. Oh, but I need to do it from peeps B, don't I? To full name. How's that going to work? Okay, well, first of all, why aren't you showing me this output? Let's back this out a little bit. Keeps a full name. Keeps B full name. It's still, I must have a syntax error. Peeps A, link the IDs, peeps B, person 2, link that to the person ID. Palash, go ahead.
I think if we like switch where friends are like join persons and replace in on your line 44, replace persons with friends, and wherever it's friends, we replace it with persons. So yeah, and you on your line.
You are totally right. Yep, because I was trying to, okay, let me.
Maybe.
Yeah, join it with persons twice, peeps. This is peeps A. So it's persons.
And so on your line 46, like we do instead of, yeah.
Yeah. You are totally right. Okay. That was not clear. Is anyone else super confused by that? Or am I the only one? Am I the dumb one in the room for once? Let's talk through how this is working, right? So we have, I'm going to break it, but that's okay. I'm going to select out my persons table. And that is right here. And I'm going to go into Excel because that's where my happy place is. I'm going to paste this in. This is my friends table. And then I'm also going to go grab my, sorry, that's my persons table. And then I'm going to go grab my friends table. I'm going to put that over here. Okay. Friends here, persons over here. We are trying to get a table that says, hey, person ID 1, Bobby McBobbyface, is friends with person ID 4, that is Shish Kebab. We are also trying to say, hey, person ID 2, right here, Lucy, is friends with Bonana Fofana. This is our end result that we're trying to get to. The problem is that we need to line this ID up from the friends table with the ID over in the persons table, but we need to do it with the persons table twice because the second person is coming in from persons as well. So what we do is we copy this and we paste it. We join on this same table twice. But what we are going to do is we're going to say, hey, my friends are this table. This is going to be my peeps A, and this is going to be my peeps B. So start selecting from the friends table and join in the A table so that the person ID 1 matches up with the person ID from the A table, the peeps A table. Then also join in the B table, but join the B table using person ID 2 that lines up with the ID over here. Then finally, what information do we want to select out from those two? We want to select out the full name from the A table and the full name from the B table. What mistake I was making was I was trying to duplicate and double join this table over here. That's a no-no. The table that we should have been trying to duplicate to do the inner joins on itself should have been the persons table, not the friends table. Now that we know that, does this make sense? We know what table to begin with because friends is containing the information from both the first person and the second person. So we know because that table has two things in it, that this person's table is the one that we need to inner join itself on, because this has all the information compared to this, which we have to reference that information twice on. So the first time we're saying we don't care about person ID 2, just take the friends, go join up person ID 1 with this person's table using the ID and the person ID 1. Great, now we've got our first column down. Now, where else do we need to go? We need to go to person ID 2, but because we already did one connection to the person's table, we alias this as A and B. And then we are able to pull out their information from that table. Make sense? Anyone want a section of the re-explanation? So think about it as, all right, this is table A, this is table B. We start from the friends table. The friends table is going to line up person ID 1 with the A table over here. Person ID 2 is going to line up with the B table over here. The way that we tell SQL to do that is by saying, hey, go get persons and call it peeps A, and line up peeps A ID with the person 1 ID. Then go get the persons table again, call that peeps B, and line up our person 2 from the friends table with the peeps B table. Now that we've got all of these tables aligned, we are able to pull out the full name from peeps A based off of this connection. And we are also able to pull out the full name from peeps B based off of this connection. The good news is this is the hardest concept that we're going to do tonight. The last section becomes much easier. Good to move on? Is there any section of that? Do we want to ask a question a third time?
I just want to ask a quick question.
Yeah.
When doing this, when I clicked on the tables to look through the tables to see, you know, the persons, the friends, the hobbies, why is it such a big deal that I have to comment out like the select from persons or the select from hobbies? Like, why can't I search, look at the table, and then tell the tables what I wanted to do after that?
Because what answer it's checking is basically whatever the tables are that are returned. And so when you're selecting the entire thing, it thinks that you are trying to answer the question with just that select to see the whole table. So because it's only expecting 2 outputs, when you're doing other selects, it's now like, well, there are more things being outputted than I asked you to do. I don't know how to grade this to see if it's correct.
Yeah, it did give me that answer, but I'm saying like in a live environment, are we able to do that? Or do you have to like look, kind of get a general and look through the tables and then comment that section out? Like does it make a difference in a live environment if it was left in there?
It depends on how you're writing your queries and where the outputs are going, right? So think about it kind of as Postman versus your API code. In Postman, you can kind of play around with it and run whatever queries you want. And then when you close it, the queries are going to go away and it doesn't matter. But what really matters is when you go into your API code and you take that query and you're running it in your code and that's generating results that your end users are going to see, that's the only thing that's going to matter, right? So right now, there is no 2 separate environments. There's no, let me just play around with it, and then here's my final answer. It's just one big thing. So it is common to write out a query, comment it out, go write another query, realize you need other data, comment that one out, go run another one, and have like multiple things going on there while you're playing around with it. But we're also going to see in Beekeeper how we can view all the data in a table without actually having to write a select query.
Oh, okay. All right. Thank you.
The on command, Natasha, is saying, hey, we've got all of this data right here. We also have all of the people over here. So how can I line up this table here with this table over here? We've got to tell it how to play a matching game. So what we basically do is we say, go look at person ID 1 from this friends table and join that onto the ID that lines up from the persons table. So what we are basically doing is saying line this up here with this over here. And that's what the on is doing.
So it's just the second part of join. It's telling you what specifically you're joining where.
Correct.
Okay.
This is telling you what you're joining. I'm sorry. This is telling you what you're joining. This is telling you how to join.
Appreciate it. Thank you.
Yep. All right, we're going to move on here only because we've got about 15 minutes and we have to get through this last section. If you want to read this, you definitely can. There are ways of optimizing your SQL queries. We won't need that in our capstones, but there are ways of basically creating what is called an index. That index allows the database to store the information that we're putting in it more efficiently so that we can write our where queries that run quicker. If you want to go ahead and read this, you totally can, but there are things like explain built into SQL that will give you a breakdown of how that query is going to run under the hood. Okay, so now we're going to talk about, we've talked about creating and reading, but we haven't talked about updating or deleting. So that's what we're going to start with now.
Let's say that we want to create tables to store the data for a diary app. A basic setup would be a users table and a diary logs table. Now, when a user wrote up their diary on the website, we would have some code to execute an insert statement like what I'm pasting in here. So this inserts 2 rows for 2 diary logs, one day after the other. First, where somebody has a horrible fight and buries their rose in 3 pounds of dark chocolate, and the next day, of course, they make up and celebrate with ice cream, as you do. So we can check to see what our diary logs table looks like now, and we can see those 2 posts in there. Now imagine that the user comes back and wants to modify their logs, maybe because they don't want to admit even to themselves that they have eaten that much dark chocolate. Now we've already inserted the data, so at this point we would need to have code that would execute an update statement like this: update diary logs set content equals I had a horrible fight with Ono's guy. Now this is telling it to update that table and set the content, but it's not telling which row to update. We need to tell the database which row to update because we don't want it updating every row with that content, just one row. So how do we find the log to update? Well, we can use the ID like that. If we didn't know the ID, we could also filter by columns that we knew were unique to the log, like user ID and the date. It was 2015-04-01. But really, if you know the ID, it's safer because you're not relying on having to filter on columns, which could actually be the same across multiple rows. If you might have a diary app where users are allowed to write multiple logs per day. It really depends on how the app and the tables are designed. I'll go back to the ID since I know the ID. Now we can do another select to see that our table changed. And it did. No more knowledge of those 3 pounds of chocolate. Okay, so the user made that change, but then the user decides that they actually want to delete the entire log entry. Like maybe because they want to forget that they even had that horrible fight. So in that case, we would need to have code to execute a delete. So we can say delete from diary logs where, and once again, I'm going to use the ID because I know it. And let's select again to see what it looks like. Haha! So we only have 1 row left, which means that our delete worked. Now, you should be very careful whenever you're doing update or delete because you want to make sure you're updating the actual rows that you intend to update. You don't want to update the wrong rows or delete the wrong rows and lose that data. In fact, some apps never issues deletes. They never really delete rows. Instead, they add a deleted column to their database, and then they'll do something like deleted equals set deleted to true when the user wants to delete, and then they filter based on deleted equals false in the select queries, something like that. So that means that you never actually delete data, which can be a little bit safer, but it's a little more complicated to do that as well. So anyway, that's up to how you design the app. So now with select and insert and update and delete, you have all of the commands you need to handle what a user would want out of your diary app. And now hopefully you can better imagine which commands are happening behind the scenes when you use your favorite apps every day.
Okay, we've got our update and our deletes. We are going to skip this challenge, although I encourage you to practice with it. You will be using your update and your delete commands a lot. The most important thing that I want to mention here, there is no undo button in SQL. So if you run a command and then go, oops, I didn't mean to delete that, it's gone, it's deleted, it's out of your database. Now you can set up database backups, and production systems certainly do that, but very, very important to make sure that you do not accidentally run a delete command. One of the biggest, stupidest things in SQL that I don't know what they were smoking in the 70s when they came up with SQL, but they were on something, because a lot of databases, and some have changed this now, but they decided that if you forgot this where query and just said delete from diary logs, it would decide. You're gonna let me edit this? No, you're not gonna let me edit it. It would decide that if I just put a semicolon here and did this right there, it would go delete every single row from diary logs with no undo button. So make sure as soon as you write that keyword delete, before you even tell it what table to delete from, please, for the love of God, do not forget your where statement, because you will delete all your rows if you just say delete from diary logs and don't specify which one you want to delete. The good news is that while our commands tend to auto run here, they will not automatically run in Beekeeper or in your API. You will actually have to hit the run button to make an API call, or you'll have to hit the run query button in Beekeeper for that query to actually go execute. So while we don't have a run button here, we will have one over in where we're actually writing our statements. So just be careful with your delete. That also goes for your update. If you forget to do your where right here, it will actually go set all of the content in all of the rows to whatever you're specifying. So make sure whenever you're doing an update or delete command, make sure that you've got your where there to specify, hey, I only want to update this on one of those rows, not on all of those rows. Definitely good to get practice with update and delete, but we have to get to that last video. Hey, this is great. We've made our table, but what happens if we try to edit our table, right? What if we decide, hey, in addition to the date, we also want to store some information about whether or not this is a private entry or not? Well, we in Khan Academy can just go back up and edit our table. But once the table has been created in a production environment, we need some way to be able to modify, or what SQL calls alter, that table. So that's what we're going to take a look at.
We're back with the database for our diary app. Now, when we first created these tables, like the diary logs table, we decided to store user ID, date, and content. And now I want you to imagine that a few months after we launch this diary app, a user designer suggests adding a "how are you feeling" drop down on each diary entry. And the user would say something like happy or sad or confused. In order to store that, we need to add an emotion column to the table. Now, we could just add it like this, but if this was a database for an app in a real production environment, then we couldn't just edit the create statement, because that's something that we actually issued months ago and it's already happened. And if we rerun it, it'll actually remove the current data. And we don't want to lose all the data that we've gotten over these many months. So at this point, after we've done create and after we've got data, we're going to need to use the alter table statement. And to use that, we write alter table and then the name of the table, and then we add, then the name of the column name we're adding, and then the data type of that new column. Great. So now the next time that the user makes an entry, we'll need to specify that column, or we can specify that column. So let's say, all right, let's say they went to Disneyland. And to specify that new column, we're going to put comma emotion. And then here we'll just say happy. Most people are happy that go there. Okay, so let's see what it looks like now if we select it all. So we can see the latest row has happy in the emotion column, and the row before it has that big old null in it. And that is what databases usually do. They fill in null for unspecified values. If we want, we can actually get it to fill in some other value for rows where it wasn't set, and that's what we think of as the default value for a column. So to do that, if we had wanted to do that, we would have put default and then the value in that alter table statement when we ran it. So now you can see instead of null, we see unknown. So that's an option for you when you're adding a column, and just something to keep in mind, depends what you're adding to the database. Okay, so now let me show you something that you rarely do, deleting an entire table. Maybe I would do this if I migrated all the data out of this table into some new table, or if I just got mad and decided to be a horrible person and take a rampage all over a database. That's bad. But anyway, we can do this using the drop table statement. And now if I try to select, what happens? I actually get an error because my table no longer exists, so it can't select from it. So that was a bad idea, and I'll just delete it. You should think really carefully about dropping tables. Do not just drop them willy-nilly. You should also be careful with alter table, especially if you're running it on a table with a lot of rows, because you can have performance issues there. Really, I don't want to scare you, but you should be careful whenever you're making any changes to your database. With great power comes great responsibility. And now you have both.
With all of that said, we have actually had, fortunately not at the last startup, not at the startup that I work for, but it is a real concern of a disgruntled employee who has database access actually going in and just running a bunch of delete commands. Well, there's no undo, so if you don't have a backup, all of a sudden that live production data disappears. So when you hear stories about people working for companies and they wake up one morning and their phone won't let them sign into their email, or they can't sign into their computer or any of that, it is to prevent that from happening, because it is very easy as a developer, especially a developer who has access to a production database, to go in and just mass delete things out. So I will give you guys the option if you would like to work on those dynamic documents challenge and the clothing alterations challenge. You are more than welcome to. That will give you good practice. But we are going to go on break, be back at 7:20, and we will dive on into getting Postgres set up and also making sure Beekeeper is working. Go on break. See you guys at 7:20. All right. We've made it through Khan Academy. We've made it through your intro to the SQL programming language. Now it's time to actually do something with it. With all of that said, I actually have Postgres and Beekeeper already installed. So does anyone volunteer as tribute to share their screen and I can show you the steps through one of y'all's computers? Shannon, go for it. Oh, Corin beat you to the screen share. All right, we'll use Corin. Thank you for the volunteer. So we are going to get started with headed to a application website called postgresapp.com. Corin, can you drag that over to your other monitor for me? It should be a Chrome window.
Wait, what you want to do?
Just have a just a new Chrome window over on this monitor.
Oh, okay. Yeah, I got you. My bad.
Perfect. Thank you. Okay. So in our browser, we are going to go to a website called Postgres. app.com. I will drop that link in the chat. From here, you
Oh,
are
wait, my bad.
going to go down to the download section. And then from downloads, you are going to hit this big blue download button here. Once we have it downloaded, we are going to pop that open. And for the love of the bejesus, do not double click on this right here. Grab the icon, drag and drop that sucker into your applications folder. Whenever we have an interface like this, we do not want to just double click on it and always run it from here. This is something called a you should not have to add a extension to Chrome first. This has nothing to do with Chrome.
Oh, okay. All right. Let me try again.
I will come back to you if that's still not working, or you can try it in Safari, but you shouldn't have to do anything with a Chrome extension. It will take a couple minutes to copy. Once it is done copying, you are going to go to Finder, go over to your, it will say Postgres or PostG right here. Go ahead and hit that eject button. That eject button is going to remove that from your desktop, so it is now properly in your applications folder. Again, postgresapp.com, downloads up at the top, the download button here, then pop that download open in Chrome. Then you will get the drag and drop, take that Postgres icon, drag it over to your applications folder, and you are done with that install. Second install is going to be something called Beekeeper Studio. I'm going to drop that link in the chat as well. If you go to why Zoom? Why do you hate me? Why are you not letting me click? There we go. If you do a search for Beekeeper Studio and do not use the link that I put in the chat, you will get to this seemingly good-looking website and be very tempted to hit the download button. Do not hit this download button. This download button is the paid version of Beekeeper Studio. We need 0% of the paid features of Beekeeper Studio. Instead, we would like the free version of Beekeeper Studio. And if you go to this download button page, they're going to be like, oh, Mac OS and Apple Silicon, and that's a do not do it. Do not be tempted by it. If you scroll down a little bit, you will see that there is a free open source community edition of it. That is what we want. So we are going to click onto that link, or you can use the link that I put in the chat, and that is going to take you to GitHub. We are going to then scroll down to the releases here and click on that latest release. It came out 5 days ago. I will personally hunt you down if you download the paid version of this. You only should be downloading Beekeeper from GitHub. Do not do it from their website. We are going to scroll down, ignore all the release notes, and the one that we want is the arm64.dmg. That stands for disk image. MG is the image part, and the D is for disk image. We don't want the block map. We don't want the .app image. We don't want the zip file. The third one down, arm64.dmg. The silicon, you have Apple Silicon laptops, all of you do, and that is an ARM-based processor chip. So we're going to download that third one. We are going to pop that open.
How'd you get there again? I'm on GitHub. I don't see contributors.
Over on the left here, there's releases 3.9.20. Click on that. And that should, if you scroll down a little bit, give you the assets section.
So I'm
ARM64 DMG, the third one down.
cool.
Then we get this familiar interface. We're going to drag and drop that into the applications folder. Shannon, if you don't have the download up at the top of your Chrome bar, you can go to Finder and then head over to your downloads folder, and it should all be in your downloads folder. You can double click on Postgres or Beekeeper, and that should pop it open for you. Does anyone need help? Tara, were you able to figure out how to get around whatever was happening?
Yes.
Cool. Anyone need help? Anyone need a minute? We haven't opened anything. All we've done is downloaded.
So we just move, once we have downloaded it, we just move the DMG files to application? Okay.
Yep. Okay, now we are going to head to our applications folder. We are going to scroll down to Postgres. All SQL databases have a mascot. Postgres is an elephant because elephants have great memory, and that's what we use databases for. If you get a pop-up that says open, go ahead and click on that. And we should have an interface that looks like this. Now, before someone asks, when I share my screen, I am on an older version of Postgres. That is okay. That will make absolutely zero differences. But if you have the newest one downloaded, it should be 15. Shannon, all I did is after it's installed, I went to Applications. In Finder, I went down to Postgres, double click on it to open. It will give you a little open dialog that says like, this is downloaded from the internet. Are you sure you want to open this? If it is okay, go ahead and hit open on that. And then we get to here. From here, we are going to go ahead and initialize our database. This is going to take a minute, but this is going to set up all the folders that Postgres needs to get started. And it should give us a green check mark that says running. And if our database is running, we better go catch it. Okay. Unfortunately, this is the most exciting thing that we get to do in the Postgres app. The database is just running in the background. Postgres is a database server, right? It has a lot of databases running inside of it, but it's a server. And what do we know about servers? We have to be able to connect to the server using a client. Well, how do we connect to a web server? We use the web browser, right? And we use a URL. But we have already seen 2 different clients so far in our curriculum. Does anyone want to take a guess at what our 2 clients are other than the browser? Postman is one client. Yep, good job, Brandy. The other one is GitHub Desktop. We use GitHub Desktop as a client to interact with GitHub up on the cloud and all of that. So we also are going to use a client to connect to our database. And the client that we are going to use is Beekeeper Studio. So go ahead and pop those open. Now, because we will be using these not only today, but until the end of the cohort, we're going to add these to our doc, just like we have VS Code in down there. But for now, if you get this pop-up, it says it's downloaded from the internet. Are you sure you want to open it? Yes, we do want to open it. That will eventually give us a loading screen. Okay, this is what we should have when we have Beekeeper open. Please, again, for the love of God, make sure that these are in the applications folder, not running from the disk image on your desktop. We never want to double click on it where we got that arrow in the application over. We always want to make sure that we are running applications out of the applications folder. Breaks in the weirdest ways possible when you try and run an application from the disk image. It will appear to work and then screw you out of things that should be working that are no fault of your own. Always make sure that when you are running an application, you are running it from the applications folder, not from the disk image that we downloaded by just double clicking on that. Okay, I'm going to take my Postgres icon, and anything to the middle section of this doc, anything to the right of the first line is what is running, but not pinned or stored into our doc. So I'm going to take the Postgres icon and just drag that over so that I can find that next time the computer restarts. I'm also going to take my Beekeeper Studio, drag that over so that I can get access to it down the road. Now, let's connect into our first database. So I'm going to close out of my applications, and it says, all right, how is Beekeeper going to connect to the database? Well, Beekeeper supports all of these different kinds of databases. We don't want any cockroaches here. We're going to go to Postgres. Now, why did we pick Postgres? There are a lot of different options here, and a lot of these are SQL-based. MySQL is the probably most popular open sourced one, and MariaDB is what we call a fork of that. It's kind of Maria started as kind of a splinter off of MySQL. MySQL is what WordPress uses, which powers a lot of websites on the internet. Postgres is the one that we picked. Postgres tends to have a couple more features. It tends to be a little bit faster. It is also open sourced. SQLite is a variant that runs off of one file, which is kind of cool. SQLite is better for smaller applications. It doesn't have all of the features of a fully blown SQL database does, which is why it is called SQLite. There are two other very popular ones. SQL Server is done by Microsoft. It is not open source, so you actually have to buy a license to SQL Server if you want to use that. And the same goes for Oracle. Oracle is not open source. You have to pay. It is proprietary software, so you have to get a license for that. And for bigger companies, sometimes that's worth it, right? Because they have other features that the open source ones don't. But Postgres tends to be a little bit faster than the other open source versions. When I asked the community of instructors and other engineers that we know, we said, hey, we're choosing between MySQL and Postgres, and no one really had a strong preference there. So there are little tweaks that will be different. The data types on columns may be called slightly different things. For the most part, though, once you learn SQL, there's a slight learning curve when you go to a different database server. For the most part, they all work pretty similarly. So anyway, long story short, we're going to get Postgres. And it's going to give us a couple things here. We are going to connect to localhost. We're not going out over the internet. We're not putting in an IP address here. We're not putting in a domain name. We're saying, hey, everything's running on my computer. Down the road, once Nathan comes back in, he's going to teach you guys how to deploy your database and then be able to connect into that deployed version once it goes live. We are setting up our first environment, right? Our environment is what our database is going to run in, what our API server is going to run in, and our local or front end is going to connect into. Port 5432 is Postgres's default port. Why is it 5432 and not something else? Well, no one else had 5432, so they just picked that one. Okay, down here, your username is going to be the username that you use on your Mac. If you go back to the Postgres app, whatever is not Postgres in template 1, you'll have a third database here, might not be in the right order, that's okay. It will tell you what the name is of your default database. So you are going to take that name and you are going to put that both in your user and for your default database. Then you are going to hit the test button and you should get a connection looks good. No password here. If your connection looks good, it may be tempting to hit that connect button. Don't do it. Come down here to the save connection, and you are going to go ahead and call that local DB. You're then going to save that, and you'll notice this now shows up over here. So next time that you go and open up Beekeeper, you don't need to put in all of these details again. You can just double click on your local DB, and it should connect you in to your database. Shay, yes, we are setting up the database. There are 2 applications we downloaded and installed. I will repost them in the chat. Unfortunately, this is a tough class to catch up on. No password, Plush. Password is left blank. Or when your free ride is over, I am going to take over on my computer from here on out. Tara, did you have a question?
That was me, Natasha. It says Bossy Tosh does not exist.
Share screen.
And
Because you have 3 S's
oh,
in your username.
got it. Thank you. So,
Hopefully.
there we go. Connection saved. Okay. Thank
And
you.
then hit connect just to make sure it's working. And you're good to go.
Awesome. Thanks.
Mine isn't connecting.
Share screen. We're running on Postgres 15. I don't yeah, Postgres 15.
Yeah.
Oh, sorry, I was answering a question in the chat. Okay, so your username here has to match whatever you're putting in right here and here.
Gotcha. Thank you.
Yep. Thank you, Taylor, for catching up.
Excuse me, Max, did you answer the question about the password?
Yes.
You did,
Password
okay.
stays blank.
Okay, thank you.
Anyone else need help? This is frustrating, it's slow because it's a lot of little steps, but better to have you caught up now and be able to follow along for the rest of class. Okay. So I am going to get my Beekeeper up and running. Okay. So let me just close out of some of this stuff. First things first, we did not learn this in Khan Academy because Khan Academy had an environment set up for us, right? But we need to be able to start from scratch. So what we're going to do is we're going to click on this little plus button up here, and that's going to give us this text editor area. This text editor area is where we're going to write all of our SQL. And as promised, we have a run button down here. This will not auto execute. Postgres is kind of confusing though, because we've got a database server. That's what we're connecting to 5432. But within that server, we have separate databases, and we'll be creating separate databases for each project that we're working on. Well, because we're kind of just playing around here, we don't really have a database that we can be working in. So what we're going to do is we're going to type in the command create database, and let's call this playground. Now, it did not magically do that for us. We actually have to execute that command. So we're going to come down here and we're going to hit the run button. And the result here, it says query 1 of 1, no results, 0 rows affected. Sorry, 0 rows affected. Well, that makes it look like our query didn't work, but it did. Most of the time when we run a SQL query, it's going to affect some rows, right? It's either going to show us the results of our database. Yes, please continue to follow along with me. It is either going to show us results. Shay, you're going to hit the connection type as Postgres. Make sure your Postgres.app is up and running. Actually, you know what? Can I throw you in a breakout room with Latonia and she can help you get caught up? Latonia, I'm going to make you co-host, and then I think you can do it from there. Okay, so sorry, now you're co-host. Okay, so we've created our database. Even though it's not showing us any rows are affected, we did actually create the database. One thing that you will learn in Beekeeper is there are 19 different refresh buttons, and all of them do something different. Our first refresh button we are going to see is up here. This dropdown will have your username in it. I'm going to click on that refresh button first, and then I've got a lot more dropdowns in here. That's okay. You're going to go down to your playground dropdown and go ahead and click on that. Now we've changed Beekeeper over. We have our information schema showing up here, but we don't have any tables created. So let's go ahead and create our first table. So I'm going to delete out this create database playground, and I'm going to say create table. And now it's like, we learned how to do this, but I don't remember how to do this off the top of my head. So what we're going to do, go back to Chrome, open a new tab, and we're going to say W3 schools, create table. And very first link, it's telling us, hey, create table. We need our table name, parentheses, the name of the column, and then the data type of that column. So let's call our table teachers. And our teachers are going to have a column called name. And that data type is going to be what we call a varchar. A varchar is like a string. It is actually identical to a string. And it is it's a little bit different from text. Text in a database can be whatever length you need it to be, compared to a varchar tends to be a little bit shorter. So if we've got someone typing in a paragraph of content into our database, we are going to use text. But because we are working with a shorter amount here, right? People's names usually are not more than 255 characters. We should use varchar instead. Why 255? Well, 255 is the limit of a varchar. So if you're taking something like phone number and you know it's only going to be 10 digits, you could do a varchar of 10. But we have to specify the length of it. So 255 is what we default to, just because names could actually be relatively long. And then we can have other data types here. So we could say number of students. And that is going to be an integer. And we don't have to specify the length on that. And then finally, we can say something like vacation status. And that is going to be a Boolean, true, false. Now you might be saying, Max, you're pulling these data types right out of your ass. How do you know what all these data types are? Well, if we do a search for Postgres data types, you'll see the very first thing is postgresql.org. Now, I will warn you, their documentation is deep. You go down a very long rabbit hole to the point where they are telling you about ranges and multi-ranges and stuff that goes right over your head. So there is a lot of good information in the Postgres documentation, but take it with a grain of salt. So if we scroll down, there is a very long list of all of the data types here, including ones that we've already started to use, like Boolean and integer and price varchar isn't in this list, but we're starting to get an idea here. If this scares you, if this is way too much documentation, you can go back and take a look at some of the other links. Something like this might be a little bit more friendly for you to see the more common data types. These are the numeric ones. They've got it broken down into monetary. Varchar, which is what we used, along with text, which is variable and unlimited length, and some other options here like date and times that we'll be getting into down the road. So we come over here and I hit the run button, and you'll notice everything changed over here. My information schema is all of the stuff that Postgres is using under the hood to keep track of the tables. We don't need any of that. So we can go ahead and collapse that. We're going to focus on our teachers. So now that we've got this done, I need to get some data in there. So I'm going to insert into my teachers, and I am going to insert into the name, the number of students, and the vacation status. And the values I'm going to use, and you can do line breaks wherever you're feeling comfortable. The values I'm going to use, I am obviously your teacher, number of students, and God knows I am not on vacation. All right, so we hit this run button and we get an error message. It says there was a problem, relation teachers already exists. What Beekeeper is doing is it's trying to go create our table again. And we're like, but we don't want to create the table again. So there are a couple ways that we can deal with this. Whenever we hit this run button, Beekeeper is going to start at the top and work its way down. And Tara, this is feeding back into your question of like, well, what if I have multiple selects? Well, we have a couple options. We can either just highlight this and then say run selection, and it will only run what we have selected, or we could just delete this out. We already created the table. We don't need to create that table again. Or if you're like, yeah, but I kind of want to keep that around for reference, we can just hit Command/, and that will put in our double dashes. Our double dashes in SQL are like our / in JavaScript. They are going to comment that out, so it is going to ignore this create table command. Now I don't need to highlight this because this is commented out, so I'm going to go ahead and hit my run button. And it says query 1 of 1, no results, 1 row affected. Run current, if you hit the dropdown, will only run the command that your cursor is currently in. So that's another good option. And you'll see that there are keyboard shortcuts down here. So you can actually just click in here and hit Command-Shift-Enter, and it will go ahead and run just the command where your cursor is. Okay, it says it inserted this, but I want proof. So I'm going to comment out my insert into, and I'm going to select my star from my teachers. I hit run, and now I've got my data. Corin.
I got the I know you just went over it, but I just missed what the teachers. What did you change for
Yep.
that?
Highlight this and comment it out,
Uh-huh.
and then hit your run button, and it
I just-
will not try to
that forward
recreate
slash?
that table.
Oh shit. No, it's not.
Command slash.
Okay. All right, thank you.
Okay. Now this is cool. And we're like, all right, this is proof that what we're learning in Khan Academy exists outside of Khan Academy. But this seems pretty tedious. Wouldn't it be nice if I could just double click on my teachers table and see the whole freaking table? And I could even hit this little drop down and see the schema of the table, the different columns that we're using there. Okay, well, now I'm going to come down here and hit this little plus button. And that plus button is going to give me this green row up at the top. Well, now I can fill this in with other information. So I'm going to try and double click in my name, and it's not letting me do anything. And I'm like, oh, okay, well, that's not great. Let's come down here. I'm going to hit the reset button. I'm going to try and double click on my name, and none of that is changing. Double click on teachers over on the left, Shakota, and that will bring you into this table. So I'm noticing over here, this says editing disabled. I'm like, but I want to edit that. What's going on? If I hover over that, it says really tiny, tables without a primary key column only support inserts. Editing of existing records is disabled. Taylor, if you're getting relations of teachers already exists, make sure you've commented out your create table here, because it's trying to recreate the table. The other way of fixing it is highlighting just the command that you want to run and then using run selection instead of just that run. Okay, well, if yours says no data, make sure you run this insert command.
I think I made 2 by accident.
2 is fine. We'll fix that in 1 second.
Feels good.
So this is a good reminder, and we'll take a break after this one, and everyone can share their screen if anyone needs help catching up. This is a good reminder that we created a table, but we didn't create it with an ID column. Databases love IDs. That's how they keep track of all the information and kind of separate all of that out. So what we need to do is we need to add an ID to this teachers table. Now, there are 2 ways we can do it. We can use that alter table command that we learned from Khan Academy and add in that ID, or we can delete the entire table and recreate it. Here's the downside to deleting tables. All of the data is going to get deleted with it. So 2 ways. We can either write the alter table command, or we can delete the table and recreate it, but we have to be careful, because if we do that, it's going to delete all of the data in there. Because we have our data right here, that's okay. We can do that. So I'm going to right click on my teachers table, and I'm going to go down to drop. We delete data from tables. We drop entire tables, including the data inside of it. So it says, are you sure? Do you really want to drop this? This change cannot be undone. What did I say right before the break? There is no undo button in SQL. So this is okay. We're going to say, go ahead and drop all the teachers. It's fine. It's not like we need them anyway or pay them a fair salary. Not me, just talking about public instructors. Hack Upstate pays me well. Don't worry about that. Okay, so we're in here. We are going to modify our create table command. And we are going to
I'm
add.
sorry, can I ask something?
Yeah.
We dropped the table, but the bottom still shows the information that was in the table, even though mine is still commented out?
Yep, that's fine.
Oh,
That's just showing us the result of this query the last time we ran it. If we try and run that query again, it will say there is a problem. It can't find the teachers table.
okay.
So it's just kind of lingering from the last time we ran that command. But that's a good question. Okay, so in here, we are going to add in our ID. And this is where hold on, I just want to make sure I'm giving you the right thing because this is important. Okay, we are going to say we're adding in the ID, and instead of auto increment, which is what we used over in SQLite in Khan Academy, we're going to call this serial. Serial just means it's going to add one after the other, and then we also are going to flag it as the primary key. Now, we haven't learned about keys yet, but we've already been using that. Whenever we did our table joins and we were saying, hey, person ID is going to join onto the ID from the persons table, we were using the key. The primary key is what is keeping track of what makes this row unique. We usually have the database generate out that primary key for us. We use foreign keys when we use that ID in a foreign table, in a table other than where we have generated that ID in the first place. That's a little confusing to you. That's okay. We're going to tackle database design probably early next week. There's a whole field of how do we design this data, make sure the columns are right. Tara.
I'm sorry. I just want to make sure I get this right. So if serial is a data type, how come we
Yep.
don't have to capitalize it like the other ones? Because they're kind of specific in Khan Academy.
You can capitalize them. That's totally fine. SQL is not particular about its casing like JavaScript is.
Okay.
The only time that casing will matter is one, for consistency. So if you call this like number of students here, you would have to do it as number of students here. The other time that it matters is whenever it's in single quotes, it's going to treat it like a string. And so that value casing is going to matter. But just like line breaks, it doesn't really matter. Normally, whenever we're using like a reserved word, something that's specific to a SQL command, we put it in all caps. But you can see that sometimes I get lazy and don't do that. So it's just this is a little bit easier to read than if I did it all in lowercase. But if I did it all in lowercase, it should all work. Okay. So with all of that said, I actually want to create the table. I still want it to insert me into the table, and then I would love to see the output of that table. So this is one of the few times that I'm actually going to hit the run button, and it's going to run everything for me. Not only did it create the table, and we can see it over here, it also inserted something into that teacher's table. And because we set it to the serial data type, it also generated out that ID for me. Man, I've got a tickle in my throat and it is driving me nuts. Okay. Now that we have created that, when we double click on our teachers over here on the left, you've noticed our error message about editing data has gone away. Well, now that it has this ID, you can see that it actually has this little key. Kenny, that's a loaded question. Let me come back to you on that. Yes, kind of, but I can rant on that for a couple minutes, so I'll come back to that question. Serial is just meaning that one comes after the other, right? terrible example, but a serial killer is called a serial killer because they've killed multiple people. The same goes for serial. It just means that it's happening one after another. And so we want that to happen to our IDs. Tasha, give me 1 second. If we hit our plus button now, we get our green row again, but this is how we can actually start putting in some additional data. Now, when I click into that field, because that ID is there, Beekeeper is happy. So we can put in some other information. Now, this is important. If it is highlighted in green, and notice I left this ID as null, it should auto-generate that ID for me. So I put in some information. I have to hit this apply button. This apply button is what is actually executing the SQL. So if I hit apply on that, you will see Latonia has been added to the database and has her own ID. And what's really cool about this is now I can go in and update this data. And now, whenever I got colors, I have to remember to come down and hit this apply button. You don't have to have this exact data, but I'm just going to do one more example. I'm going to add in. And before I hit apply here, I kind of want to know what Beekeeper is doing, right? We understand what's happening here. It's going into the database. We can see all of it, but we can actually go down here and say copy to SQL. And if we click on that, you can see it's doing our insert into. And yeah, it might be using more quotes than we're used to it using, but we can actually see all of that data, all of that SQL that it's generating. And if we go back over here and hit reset, it will remove that out. But I can go back to my query, hit run selection. Boo. That should have worked. Try that again. Have to take out the public dot there. Anyway, you hit that run button. And now if we go back to teachers, that data isn't there. We are now going to see refresh button number 2. We have a refresh button up here to refresh the list of databases. We also have a refresh button down here to refresh the data that is in this table. So if you go ahead and hit refresh there, you will see that new information show up. Okay, Natasha, now you can go ahead with your question.
I can't do a darn thing that you just talked about for the last 3 minutes because I was stuck on the, excuse me, the ID. After we added the primary key, I didn't kind of see where you opened that window from. So then you just kind of kept going and I'm still on that.
So it's back in query 1 where we wrote our initial stuff. Once we did this ID serial primary key, make sure your teachers table is dropped. If you don't have public teachers, it already has been dropped.
Right.
And then you can just hit the run button down here and it will run all of those commands.
Perhaps I did not drop it. Let's try it again. Drop completed successfully. Run. No, it's still saying teachers already exists.
Here, let's take a look. So let me request. Right click, drop. Drop. Now we are going to do run. That makes all of your teachers. And now we're done with that. So when we go over to teachers, we can now see the teachers has an ID.
Ooh, okay.
So if we go back to our teachers table and refresh, our data is in here. And then we can start playing around with adding things in here. and hit apply, and that will save your data in. And then we can also do things like right click and hit delete row. And when we hit apply, it will remove it out.
Beautiful. Thank you.
Or double click to edit and then hit apply, that kind of stuff.
Okay, appreciate it.
Yeah. Sorry, we've got Zoolander and Austin Powers going on tonight. Particularly proud. Okay. The last thing that we are going to do tonight is pull in data from another source. So if we head back to Khan Academy, which I know I promised we were done with, but I forgot about this step. And go down to the project data dig. I will post a link in or a message in the chat. Up at the top here, they've got all these different data sources. And if we click in on one of them, I don't know, the solar system items, we can see they've written a bunch of SQL for us that we can actually just copy and paste. So I am going to copy this, start at the top, work your way all the way down.
We can't see your screen.
And Kenny, what a wonderful face it is. Sorry, up at the top, start the link that I got this from, I posted in the chat. You can pick any one of these data sets. So I just picked solar system objects, doesn't really matter which one you pick. I'm going to start at the top, work my way all the way down to highlight all of it. Chrome's going to hate me. Try this again. Highlight all the way down to the bottom just of that text. Really should be an easier way to do this, but I don't know of one. Copy all of that. Come back over to, fine, I will do Pokemon. What in God? Give me a second. My air conditioner randomly turned on and is not turning off. What in? Give me a second. I need to go kill the breaker because I think Internet of Things is now melting down my house. So give me 2 minutes, try and get that that data inserted, and I am going to go pull a couple plugs and I will be right back. Skynet has officially taken over. Sorry, so I've got like wall mini split units, and the fan just turned on all of them, and I hit the off button on the remote and it wouldn't turn off. So I checked it in the app and it says central control locked. And I'm like, what? I'm pretty sure LG either just had a security vulnerability or pushed an app update and didn't mean to actually do that in production. And now I bet you there is going to be a news article that everyone's internet connected LG heating systems like all turned on all at once. And I'm sure it's going to be a big deal. So anyway, back to our regularly scheduled program. I will keep you updated as to what happens there. Okay, share. Back to here. I'm going to go to Pokemon. I think if we go to the raw one and just hit Command A and Command C, that's an easier way to get all of it. So we're going to copy that. We're going to go over to here. I'm going to, I don't need any of this, but if I wanted to, I can go into a new query window or just hit this little plus button up at the top. That will get me into a blank text area. I'm going to go ahead and paste all of that in. And I'm going to hit the run button. And it says no results, 1 row affected. Okay. So I'm going to go back over to my Pokemon, double click on that. And now I've got all my Pokemon loaded into my database. Okay. From here, I want you to use the last 15 minutes of class. Practice playing around with Beekeeper. Practice adding a new row into this table. Practice deleting a row. Practice updating values. And then also practice some SQL commands. See if you can do a self-join. See if you can get some information about, you know, make a select filter that says, hey, show me only all of the fire Pokemon or whatever you're doing. The other thing that I can show you is up here, there's a search interface built in here. So we can actually do that, right? We can say, hey, show me all of the fire Pokemon. And if I hit this little search icon here, it's going to show me here are all of the fire Pokemon, and it will give me the information on that. Kenny, there isn't really a prettier in Beekeeper, at least not that I am aware of. However, once we get back into our JavaScript tomorrow, we'll be writing SQL commands that execute, and prettier will run on those. But no prettier built into Beekeeper. So you've had enough for the evening. You are welcome to head out. I will hang around for a couple minutes if you want to play around with Beekeeper, see if you can write some SQL queries, see if you can use the tools built in, play around with it, see what you are thinking. I will stick around for questions while I figure out what AI has taken over my heating system. And otherwise, have a great evening, and I will see you guys tomorrow. I don't know if whoever came in late, Open Hack is not this Thursday. It is next Thursday. Mike moved it back a week due to a family vacation. So we will be in class on Thursday, and we will take next Thursday off for Open Hack. Like I said, I will stick around if you guys want to play around, find some data. It's totally fine. Right, see you guys.